Hey there. In this video, I'm going to talk a little bit about optics. I'm going to show you how to determine the position of an image depending on what type of lens you're using and where your object is located. Okay, so if you're watching this video, I'm sure you're aware that there are two types of lenses and mirrors. You got converging and diverging. Alright, now as a rule of thumb, all the diverging mirrors and lenses, right, they create what we call as SUVs, meaning they create small images, upright and virtual. Okay, so on a test, if you're given that you have a diverging lens or a mirror, then right away you know that your image is going to be small, upright and virtual. Okay, now moving on to converging mirrors. Now this is a little bit tricky, okay, because the position of the image depends on the position of the object. So let's see how that works. So you got this lens, right? This is a converging lens or a mirror. Okay, let's just say lens for right now. This is a converging lens, and then as you know, on a lens you got 2 points. One is the focal point, and the other is the radius. Okay. So we'll go through every single possible location that your object can be placed at. Okay, so let's start off from outside of the radius. Let's say your object is out here. Okay, this is your object, and this is your lens, and your object is located outside of the radius. Now, where is the image going to fall? The image of it will be between R and F. Okay, not only will it be between R and F, it will be inverted, and it will be small. Okay, I guess you can see already that the size of the image that I drew here is relatively different. The object is bigger and the image is smaller. So if the object is beyond the radius, the image is going to be between R and F. It will be smaller and it will be inverted. Okay? Now, what if the object is at R, right, exactly on the radius, right there? Okay? The image of this guy will also be exactly at R. It will be inverted and it will be of the same size. Maybe I drew the image a little bit longer, but let me say here that it's going to be the same size. Oh, this arrow is confusing. Anyways, this is the same size as the object. Okay, so we got 2 cases so far. If the object is beyond the radius, and if the object is on the radius. Okay, and now let's move on. What if the object is between R and F? Okay, this is kind of a flip case. So say, for example, this was your object, right? And this object is between your R and F. This image will be outside of the radius. Okay, it will be inverted and it will be bigger. Okay, so image of this guy is going to be outside of the radius. It is going to be bigger and it will be inverted. Okay, so far we've covered 3 cases: object outside of the radius, object on the radius, object between radius and focal point. And now the 4th case will be object on the focal point itself. When the object is exactly on the focal point, then you will not form any image. Okay, that's like a blind spot of a lens. So you will not form any image if the object is located on the focal point. Now the 5th case is if the object is located between the focal point and the lens. Okay, so if the object is here, right, then its image is going to be on the other side of the lens, which is the virtual side. Okay, so which is pretty much this side of the lens. So its image is going to be bigger and it will be upright and it will be virtual. So this is the virtual side. So I hope that was easy. So let me review it. If the object is beyond the radius, if the object is located beyond the radius, then its image is going to be small, inverted, and it will be between the radius and the focal point. Okay? If the object is on the radius, then its image will also be on the radius, and it will be of the same size, and it will be inverted as well. If the object is between the radius and the focal point, then its image will be bigger beyond the radius, and it will be inverted. If the object is on the focal point, then there will be no image. Okay? If the object is between the focal point and the lens, then the image will be on the virtual side. It will be upright, and it will be bigger. So the only case where you have an upright image in case of converging lenses and mirrors is when the object is between the focal point and the lens. all the rest of the cases, excluding the focal point obviously, the image is going to be inverted. Okay, so I hope that was helpful.